Sophia, working in weed ecology and invasive forest pests. We have studied ecology across the country, including forests in New York, prairies in Washington State, riparian systems in Oregon, arid lands in Colorado, and lakes in Ohio. And she was introduced to agricultural systems when she joined the East Mosso Lab at Cornell in 2010. She's been working with agricultural needs ever since. So with that, Terry. Oh, there we go, Sophia.
Yeah,
So you're gonna have to tell us about yourself.
a whole lot to say. My CV is less impressive, but I'm also part of the Digital Lab. I'm one of Tony Digital's students in our weed ecology and management lab. And I also study characteristics of weeds and help us understand how best to control them. You're getting Carrie in 1 second. She's going to talk about the specific weed. So before we get started here, one more plug for the book, Manage Weeds on Your Farm, which really is an incredible resource, both for understanding sort of the general characteristics of weeds and some specific cultural and mechanical tools, and for having profiles of, I think it's 63 individual weed species that are just very important in our region, and about which Chuck Mueller, who is formerly a member of our research program for weeds, providing very detailed ecological and control. Can you just put the mic just a little bit closer? That better? Thanks. One more resource. This book was also published just this past year. I think this is coming in now a little bit. Is that better? All right, cool. Weeds of the North, 2023, second edition. It also has details about more than 500 weed species that are pretty common in the Northeast, some of the Mid-Atlantic and Midwestern states. Would it be easier if I just yelled?
The other mic.
I think go to the other side of the room. Go closer to the podium.
Over here?
Yeah.
Give that a shot. Sweet. All right. So what's going to happen here is that I'm going to say some things about general principles in the control of weeds based on their ecology. And then Carrie's going to talk a bit about how these, I think this is better, apply to really specific species. A lot of the things we've got here are focused largely on the seed and seedling stages, mostly because that's when weeds are the most vulnerable to control. However, a good ecological weed management program is going to involve that attack weeds at different stages of their life cycle. So we're also going to talk some about weed crop competition and what you can do to sort of tilt the balance of power in favor of those crops. First point here, seed wings. Most weed seeds are small relative to crop seeds. And that's a good thing from where we're standing. Crops do start out with a competitive advantage. And if you can help them keep that advantage through the course of the growing season, then your weed problems will be much less. Although most weed seeds are smallish, some weed seeds are really incredibly small. And it's in those species, things like a pigweed or lamb's quarters, that we have access to a special set of tactics that may be especially effective against small-seeded weeds. One of these tactics is mulching. So mulches can be especially effective against small-seeded weeds for a couple of reasons. One of those is that small-seeded weeds tend to require a bunch of different cues to germinate. There's often a temperature thing. They want pretty warm and pretty fluctuating temperatures. And there's often also a light thing. They do want access to light. And the mulch sort of acts as a buffer. It keeps those environmental signals from making it down to where the weed seed is buried. For that reason, then often a small weed seed won't germinate at all if it's under a pretty decent layer of mulch. The other reason that mulch works especially well against small-seeded species is that it acts as a sort of physical barrier or impediment. So small seeds, not a lot of stored up energy there, simply just won't have the power to make it through a thick layer of mulch. Another tactic here is competition from an established crop. So if maybe you've got an early planted crop or a late emerging weed, and there's already some shade on the soil surface at the time that the weed is coming up, a small seeded weed species just isn't going to be able to muscle its way up through that crop canopy and start becoming a real competitor. Of course, competition is effective against all weeds, not limited to small seeded species, but inhibition is often best if the weed doesn't have many resources available to it to get started. One more here, shallow cultivation. So this is an emergent step thing. Small seeded species generally only emerge if they're buried really shallowly in the soil, often like in the top inch or so. Larger species can emerge from deeper down, and they may be emerging from below the operating depth of some of these implants. This is just the emergent step thing. So this is Herigalensoga, tiny seeds, and only emerges from quite shallow in the soil. Other factors affect maximum depth of emergence too, but seed size is probably the major one. Some more examples here. A lot of weeds are going to be often emerging from the top inch or maybe the top couple of inches. There are some exceptions, like I think we've got velvet leaf on there. Yeah, pretty big seeds can emerge from deeper down. Also, if you're looking at a perennial that's emerging not from a seed, but rather from a vegetative organ, something like a horizontal rootstock or a rhizome, really all bets are off. Because in that vegetative organ, there's a ton of stored up energy. And it can use that energy to make it up through quite a lot, 6 inches or more. This is an awesome example. This is yellow nutsedge, which emerges from tubers like this one. Yellow nutsedge often comes out from the top 8 inches, but it can emerge from even deeper down, like a foot or more. It's kind of incredible. That brings us to seed germination. So as Erin mentioned, there are a bunch of cues associated with seed germination. Some are related to temperature, light, sometimes there's an oxygen or a nutrient thing. Different species respond to different things, and most species respond to multiple things. The key point here, from a management perspective, is that most of these cues are things that happen in the context of disturbance. So tillage promotes seed germination. Logically, the reason for that is that weeds want to be germinating in places that are less competitive, where they won't have like a lot of crops or other weeds in their way, taking up all the resources. So when they get cues associated with the soil disturbance, they're like, yeah, it seems like a pretty good open area. I'm ready to go. There are a couple of ways that one might reasonably respond to the fact that tillage promotes disturbance. Some people limit tillage. There are, of course, also other reasons to limit tillage. And other people try to make use of tillage. That strategy makes a lot of sense too. An example of a way that one might make use of tillage is a false or stale seedbed practice. So here's one way that a false seedbed could look. The idea here is that you prepare your seedbed like normal, but then instead of planting directly into it, just wait. The soil disturbance is going to stimulate the germination and emergence of your weeds. And then once the weeds have emerged, you can go ahead and kill them. I think on this graph, we've got a harrow. So it's a false seedbed because the killing is a mechanical physical action. If the killing were with more of an herbicide or a thermal tool, something like that, the term would be stale seedbed, but it really gets us to the same place, right? You disturb the soil, the weeds come up, you kill the weeds, and then you plant into a much less weedy field. There are disadvantages here. Notably, it may delay your planting. But tactics like this are often really effective, especially in crops that are less competitive, carrot or onion or something like that. I want to zoom out a little bit. So we just talked about how tillage can affect sort of the specific date on which weeds are going to emerge. There's other factors at play when we talk about what's affecting the general season in which weeds are coming out. One of these is seed dormancy. So ecologically, seed dormancy is a block to germination that prevents germination at the wrong time. Like for lots of spring annual weeds in the northeastern US, temperatures in kind of the late fall are often warm enough because, weather's variable. You have some really nice fall days. However, if the weed were to actually germinate in the late fall, without the ability to tolerate cold winter temperatures that are about to happen, so from the weed's perspective, not great. What keeps the weed from germinating at this unhelpful time is dormancy. Mechanistically, there are a couple of types. Most weeds have either physiological dormancy or physical dormancy. Physiological dormancy is maintained by chemicals. Physical dormancy is maintained by the seed having a super hard seed coat that's got to be beat up a little bit before the seedling can actually emerge. But regardless of the mechanism of dormancy, it's one of the factors, kind of one of the major ecological mechanisms that gives rise to these patterns of emergence, like this one here that Aaron just showed. Patterns of emergence are relevant to control because they affect how easy it is to go in with like a mechanical or chemical operation and get most of the seedlings that are going to come out that year at the vulnerable seedling stage. This is pretty easy to do with species like some of the smart weeds. You might need a couple of different operations, something like a horseweed that's going to germinate at a couple of different discrete times in the year. And with continuously germinating species, it's a lot trickier. You might need repeated operations and also just to rely on sort of continuous weed control practices like crop competitiveness. One more point about weed emergence and when it's timed. Different weeds' life cycles are matched to different crop life cycles. Like you've got a spring emerging weed, like some of the foxtails, that's going to grow for the entire growing season and then set seed a little bit before the harvest of a full season spring planted crop, something like corn. In the same way, you've got weeds that are really common in summer veggies, like I think I've got common purslane there, galanzo is another great example. And you've got fall emerging, like shepherd's pie, that might be especially problematic in fall planted crops, like winter cereals. The fact that weed life cycles match crop life cycles is one of the reasons why weeds are so problematic. But at the same time, you can make use of the fact when you plant rotations. So if you've got a particular crop that you're trying to grow, and you've got weeds that are especially problematic in that crop, then rotating to a crop with a notably different life cycle is going to be the best way to disrupt the cycle of those problem weeds. Like going away from a spring planted crop to a perennial forage or something, if you can swing it, if you eventually rotate back to the spring annual crop, your weed problems are going to be a lot less. One more point about seeds. So I feel like we sometimes talk a lot about how seeds can persist for a really long time in soil. And it makes a lot of sense. It's incredibly important to weed management. To understand that species like velvet leaf over there can last for decades and decades, much longer than the practical time frame any of us are working with. However, most of the seeds aren't going to last that long, right? Either they germinate and they emerge and become problems, or they instead die. There are basically three ways that seeds die. They can either physiologically decay, they just break down, they can get eaten, or they can fatally germinate. Like if they're buried too deep down, so they germinate, they start growing towards the soil surface, but they never make it up there. There are a couple of reasons relevant to weed control. One is just to understand that all of these mechanisms of seed death are influenced by management actions. And to note that preventing seed production is the key to long-term management, just because none of these mechanisms of seed death can be forced to work 100% of the time. It's always going to be a numbers game, right? Some seeds are going to make it through. The good news is that pretty much all weed management actions have the potential to reduce seed production. So a lot of the best tools available are going to work particularly for annual weeds at that sort of early seedling stage. But if you've got a stage, then mid-season and late-season control measures can still be super effective. Even if they don't successfully kill the weed, that's pretty big and sturdy by that point, if they can reduce or prevent seed production, that's going to have a major beneficial impact in future years. This one just highlights the fact that many of the most impactful natural enemies of weeds are going to be those seed predators. So for instance, if after your fall harvest, some weeds have that seed, but you don't do any post-harvest tillage, then ground beetles, crab beetles, crickets, things like that can really go to town with weed seeds that are left on the soil surface. Most weed seeds are vulnerable to predation to some extent, although it does depend a bit on their seed coat hardness, their seed size, things like that. There are also vertebrate seed predators, and there are just other natural enemies. There are pathogens. There are lots of other organisms that sometimes attack weeds. Moving on from seeds, many perennial weeds are capable of vegetative reproduction. A big group of creeping perennials have special organs to do this, things like horizontal rootstocks or rhizomes like Erin was talking about. Others normally reproduce by seeds, but sometimes a farming operation, like a tillage operation, can lead to some sort of accidental vegetative reproduction. Regardless of what the vegetative organs are called, it's often things that look and work similarly, have different botanical names. They tend to have a couple of pretty similar functions. They're good for storing materials. They enable emergence from deeper in the soil, earlier in the season, and with more initial competitive ability, which really helps those perennial weeds compete against crops. These perennial below-ground organs are also great for recovery from any sort of above-ground damage, whether that's chemical or mechanical, herbivory, anything like that. And they enable weeds to even multiply sometimes after they get broken up. Most below-ground storage organs have a bunch of different buds on them, and when any one of those buds can become a new plant in the event that the organ gets broken into little pieces. There are some good ways to control perennial weeds. So, as was discussed in the last section, it's mostly about repetition. Like removing the above ground tissue on a perennial weed once probably won't lead to mortality, but doing it repeatedly at proper intervals will. This process is going to be easier and better if it's done in the period of the weed life cycle when reserves are low. Fall can be good, spring can also be great. Often the minimum points of resource availability to the weed in the spring is going to be somewhere around like the 3 or 4 leaf stage. It varies a little bit between species. Like for Canada thistle, it's about 12 inches tall. Some period in the weed life cycle in which it hasn't yet had the opportunity to photosynthesize a whole lot. So carb availability in those below ground organs is going to be pretty low. Pieces can also work. Normally, fragmenting below ground storage organs doesn't necessarily lead to mortality in itself. However, any little plants that form from those fragmented organs are going to be smaller and weaker than the original parent plant. So maybe they're more vulnerable to future control efforts if you're willing to do a second operation. And especially in some species with kind of sturdier below ground storage organs, breaking them up into longer pieces that can be worked up to the soil surface is also an effective strategy. On the soil surface, these storage organs are much more vulnerable to something like death by drying out. That's it for reproduction. The second half is going to be shorter. We're just going to chat a little bit about weed crop competition. So based on the difference in seed size, crops do start out with an advantage. Weed seed leaves can be different sizes, but almost none of them are as big as something like a corn seedling. However, relative to their size, weeds are going to grow really fast. So the period of time in which crops have an advantage is pretty short. And management actions are usually required to help the crop maintain that advantage for the course of the growing season. Crop competitiveness is sort of an essential part of this picture. And when we talk about crop competitiveness, a lot of the time we're mostly talking about shipping. Competition for light is asymmetric, meaning that a taller plant with a really good closed canopy is going to keep any newly emerging weeds from doing much at all. Lots of factors contribute to the ability of a crop to close a canopy. One of those is crop species, but things like cultivar, uniformity, planting density, grow width, all matter as well. And in some species, of course, it's possible to do something like transplant or intercrop. Competition for light is super important, but it's not everything in the context of crop weed competition. Another really interesting factor is allelopathy, which means that one plant poisons another. Some weeds are capable of poisoning crops. Some of the sorghums, like this is Johnson grass and quackgrass, are good examples. And the other way around, some crops are capable of poisoning weeds. A lot of our cover crops are this way. Rye and some of the vetches, we've got some buckwheat over there. Important points about allelopathy. It can be super variable. So it's probably not the best. It's not a good idea to base weed control programs around any single practice. But this one in particular might sometimes let you down if you don't have a lot of other things to back it up. And anything that can poison a weed can also potentially poison a cash crop. So it's often a great idea to have delay between incorporation of an allelopathic cover crop and cash crop planting. Moving on, another factor that affects competitive dynamics between crops and weeds is nutrient use. So weeds are generally awesome at nutrient use. Relative to crops, they're frequently very fast at nutrient uptake. They can concentrate nutrients at high levels in their tissues. And they tend to be pretty responsive to nutrients. So if you add more, you get a larger root, even beyond the point at which that stops being true of the crop. This is a generalization, of course. Nothing's 100%, but this is true a lot of the time. So in these little graphs, the horizontal axis going from left to right is more nutrients. The vertical axis going from bottom to top is a bigger weed, more growth. The three panels on the left are weeds, and the two on the right are crops. Corn at the top right, and then lettuce at the bottom right. What these graphs are saying is just that in all three of the weed species, and also in the lettuce, if you add more nutrients, you continue to get more growth, even to quite a high nutrient level. By nutrients here, we're generally talking about N. This is super true in corn. So in corn, beyond a certain point, the response to additional nutrients is pretty lackluster. So this is just one way to illustrate the pretty familiar idea that getting the right fertilization rate is really important. Fertilization rate also isn't everything. Things like fertility source, the timing, and the placement of the nutrients can also really be tailored to maximize the percentage of the fertility that's going to the crop and minimize the percentage that's going to the weeds. Right? This is all about just maximizing synchrony between the crop nutrient demand and what nutrients are being supplied. Drought resistance. This one's a little bit murkier than nutrient use. Weeds are kind of all over the map with respect to drought resistance. A couple of them will die pretty easily during droughts. Some of our winter annuals aren't that way. However, most weeds, like most crops and most other plants, can kind of hang on for a couple of weeks of droughts, and then are more likely to start growing again once the drought ends. There do exist a subset of weeds that have special physiological adaptations that enable them to really thrive under drought conditions. Weeds, Johnson grass, things like that are great examples. And those may be especially problematic in really sunny or dry years. There are also some species that don't have any special physiological adaptations, but they do have a morphology that enables them to form really deep roots that access water far down in the soil profile. So these weeds may be sensitive to drought when they're young seedlings, but as soon as they get those roots growing, they're pretty much invulnerable. Frost sensitivity also varies a lot between weed species. It's relevant from a management perspective because frost sensitivity can help one determine whether a late season cleanup operation is going to be necessary or whether any late emerging weeds that may be remaining at the time of harvest are actually going to be killed by frost before they have the chance to set seed. Because frost sensitivity varies a lot between weed species, and it's not usually easy to make generalizations based on weed life cycle or morphology and things like that, it's best to just look up the specific weeds that are causing you problems. There are fantastic lookup tables in that Manage Weeds on Your Farm book that we've shown. That one, right over there. And there's information for many of our most common weed species about how they're going to respond to things like frost, also drought, nutrient responsiveness. It's a great resource. If neither these environmental stressors nor any management applications do kill the weeds, they're going to set seeds and seeds are going to disperse. Some species disperse seeds pretty continually throughout the season. That's sort of problematic from a management perspective. Others tend to form their seeds pretty late and hold on to their seeds for a while. These are species for which something like a harvest weed seed control measure might be more effective. Dispersal can happen in a lot of ways. There are natural pathways, but with weeds, agricultural pathways may even be more important. Weed seeds can be moved around the farm, on boots, tires, things like that. Sometimes they can also be moved much longer distances. Something like a contaminated seeds shipment, or contaminated amendment, like a combine that's being moved from continent to continent. These are basically the ways that new weed species get introduced to totally new regions. We all know that weeds are super bad, but we just wanted to close by noting that pretty much any organism has multiple effects in an ecosystem, and some of the effects of weeds are sometimes positive. They do sometimes help improve soil health. They can promote some beneficial insects. Sometimes they act as resources for humans. So kind of a major future direction in weed research is to try to figure out if we can get rid of the negatives while keeping some of the positives. Probably not a one-size-fits-all answer to that sort of question. Anyway, that's what we've got for general ecological principles. Now I'm going to hand it over to my colleague, Carolyn Marschner, who's going to chat about specific weed species and how these principles apply.
That is a hard act to follow. Thank you. Can you guys tell me, with a show of hands, how many go from Lower Hudson, if anyone? Okay. How about Hudson Valley? Okay. Western New York? Finger Lakes? To North Country? Where are the rest of you from? Right here. After.
Thank you.
Okay, so you guys all know about this one already? And you're gonna hear, I'm hoping you're gonna hear a bunch more about this one and also about how to manage it with herbicides from Lynn, who is totally the pro on that. But I want to give you the more cultural control end of this. So this one's extra drought tolerant. We've already talked about how it emerges over a long time, which makes it hard to capture with one set of cultivation or chemical practices. Good news is that the seeds are so small, they just don't persist very long. So if you can get a handle on it, it only takes a couple of years to wipe out the seed bank. Can you guys hear okay? Okay. But then I'm really loud. Is that better or is it overwhelming? Okay. This one gets eaten a lot if you leave the soil, the seeds at the soil surface over the winter. But because it grows so fast, it's not a good one for using shade so much. You would need a lot of shade and you need it really consistently across the growing season. So it's not a great option for this one. This one, because again of the rapid growth, early and timely management is really the only way to get a handle on it. If you're doing mechanical treatment, what Chuck recommended was 4-day interval, come back into the field over and over again, blind cultivating. Actually suggested if you're planting a large seeded crop, to plant it a little deeper than usual, so that you could come in and blind cultivate over it a little bit longer. And then a very slow tine weed or rotary hoe over the top, as long as you can, until you can't get into that crop anymore. What might make more sense would be if you have this come into your field and it becomes a problem to rotate into a perennial sod for a few years, to just wait out that couple of years until the seed bank dies out. But these do hold on. They're one of the weeds that Sophie was talking about, that they produce 500,000 seeds in some cases per plant, but then they hold on to them, most of them, even after the frost. So this is a good one for a seed destructor or some kind of harvest during collection and seed destruction during harvest. The downside is that because all those seeds are on there, when you're doing your cultivation, the seeds get all over your combine. And actually that's how Palmer wound up here, was that somebody bought a secondhand combine from the Midwest. And they thought they had cleaned it, but the Palmer showed up in the first field they used it in. They're just really small and they're really hard to get out of the combine. So there's a zillion things online you can look at for ways to really clean your combine when you buy a used one. Planting in high corn density can really help, and irrigation to help make your crop more competitive. In vegetables, black plastic mulch works. It won't come up through the black plastic, and if you're doing like a pepper crop, as long as you get the ones that are coming up through the holes sometime in the first 5 weeks, that works pretty well. And cover crop mulches are really helpful, especially cereal rye, for its allelopathic properties. Another related plant, water hemp. It's not as drought tolerant as Palmer. This one, tillage is really helpful. Winter grains are great for suppression of seed production, but it's not great to do a hay crop right after grain, because you'll get a whole bunch of seed rain before you get that first cutting. What you can do is wait for it to grow a little bit, cut it before seed production of the Palmer, and then just wait a little bit longer for your hay to finish coming in. Cultivation works pretty well because it may be multiple herbicide resistant, but not to steel. And for vegetables, this one, the early fallow that works so well for a lot of our other
summer annuals, this just emerges too late. It was in group 6 in the tables that he was showing earlier. And so for this one, something that you harvest in the summertime is in that field is going to be a good option. Organic mulches are good. And that little round picture on the natural enemies slide was actually a fungus that's specific to the amaranths that there's been a little bit of interest in as a bioherbicide, which would be awesome. Foxtails, we have 3 species in New York. The most problematic in field crops would be the giant. It's just bigger and more competitive. It's especially an issue in no-till. The yellow's a little more drought tolerant, so you might have more of a problem with that in a dry year like last year. They all love extra fertility, especially the giant, which is one of the ones in that fertility graph that Sophie just showed. But the seeds are delicious, so if you leave them on the soil surface, a lot of them will get eaten. Shade works really well for these. Winter grains, oats and barley, do a really good job at dropping the populations of foxtail. Some cleanup post-grain harvest is helpful. And rotating into early vegetable crops that have a midsummer harvest just interrupts the seed production for this species. We did have somebody ask a specific question about foxtail millet. And if you were talking about wild foxtail millet, this is it. If you're talking about the kind that you plant on purpose for millet, it's a different species. Gypsum weed is an issue in pastures. It's pretty poisonous. It's poisonous to humans, it's poisonous to livestock. It's not something you want in your farm fields. It is one of the last things to emerge. And the seed bank duration can range from a few years to a really, really, really long time. This doesn't do as well in no-till. So if you have a field that has problems with gypsum weed, you might consider shifting that into more of a no-till pattern for a few years. This one's very responsive to fertility. So if you could plant a light feeder and starve it for a while, that would probably help. This is another one, I don't know how it gets predated given how poisonous it is, but it does. It's a good idea to look out for this around, because it loves fertility so much, it tends to grow around manure piles and compost piles. So keep an eye out for it and control it in those areas so you don't wind up with seed rain into your compost and manure that you then spread on your fields. This one, when it's in light shade, it'll grow really tall, and almost all of its biomass will end up above your crop. So this is a good one for the weed zapper or a really high mowing if it escapes over your crop, because it can't produce very much seed because you've taken off most of its biomass. That's a good way to deal with escapes. The seedlings are pretty robust. They don't come out very well with tine weeding or rotary work, but they do get buried pretty effectively. And if you can get really, really deep shade, deep enough that it can't power through, that does work. So higher density planting, narrower rows. Eastern black nightshade is not that hard to manage in most things, but if you're growing edible beans, peas, food grade soybean, it stains the crop and makes it less valuable. This is another one that loves nitrogen. And another one where relatively high seeding rates, more than you normally would if this is a problem in your field. And narrower rows if you can. And another one that doesn't do as well in no-till because it really needs that disturbance for germination. Tilled fallows work really well for this one, and interspersing adding to your rotation some kind of short crop where you're gonna be able to harvest and interrupt its life cycle will help. Sod is nice. And this one shows up in overgrazed pastures. So if you're starting to see a problem with gypsum weed in your pastures, you might rethink your grazing strategy for that land. Mullein is a biennial. I have it in my yard. It makes a little rosette in year 1, and then it makes this spectacular fall spike in year 2. It's usually not a huge problem. It's usually ephemeral. It'll come and then it'll get out competed by other things. Glyphosate works fine on it for a spot application. And reseeding is something that will outcompete it because it's not too hard to outcompete this one. And it's not, especially early, it's not that bad to handful, but I think you can just top it to keep it from setting seed. Chickweed is one of the nasty ones for vegetable growers. And it, particularly because it just sets seed all season long. But these are one of the seeds that require a light trigger. So if anything in your rotation is sensitive to chickweed competition, it's a good idea to go ahead and control chickweed in all of your crops, even the ones that aren't affected by it, just to keep the seed bank down. Higher density of winter grains will help. And for this one coming through early in the spring, while it's still relatively small, and doing frequent shallow disturbances will help just pull those out of the ground. And they reroot really easily though, so try to do it on a dry day. And once they get biggish, then they're a lot harder to pull out readily. If you're doing small seeded vegetables that are going to be really sensitive to this, because it needs light, if you do a stale seed bed, remember that's the one where you don't cultivate again, so you do your seed bed preparation, and then wait a couple weeks and flame weed or do a chemical treatment. You get your flush of emergence, and then you're not disturbing the soil again, so you're not going to get another round of disturbance because they need that light for germination. And organic mulches work great for this one because they're really small seeded. But with loose straw, because they're so flexible and bendy, they can just grow right through it. So if you're using loose straw, like a paper mulch underneath, will work better. Wild mustard was in that very first emergence group from Aaron's slide. And it's hard to control with cultivation because you have this big flush of very early emergence. It's already pretty established, usually by the first time you go in, and then it continues to emerge into the mid-spring. And it gets a really big root system really early, so it's hard to get out once it's established. And it loves nitrogen. This one, a tilled spring fallow works pretty well with a late planted crop. For this one, if you have a lot of mustard in your field that you're in a crop that you're going to side dress, if you can delay side dressing by 2 or 3 weeks, it makes a big difference to how big the mustard grows and how many seeds it produces. And cereal grains and other things that produce a dense shade are really effective at managing mustard. I'm almost done with the annuals. Burr cucumber can be a really serious field crop weed. It's more a problem in the south. This is part of why I was asking where you're from. Because this is a okay, thank you. I was gonna say it's more of a problem in Pennsylvania, but it's coming for us. It emerges in the early spring, it's a huge root system, and then just scrambles all of your plants. This is another one where a tilled spring fallow is really useful. And a late planted crop. Those are the same ones. I'm just going past that. Does anybody who actually lives here and has this in their fields have advice for this one? Really?
Then you don't want to touch it.
You ever tried late planted corn with the pre-emergent herbicide and the, post-emergent application?
No. That's no. It seems to like what we've seen it likes the better soil, really good hydroponic soils. There was shallow about it. Seeds. Pretty good size. It's still trying to clean up good and make it all the things. Somebody else's farm seeded in. It actually gets up to the chopper. It seems to ride through the fermentation process with the silage pile, then goes to the animal.
I think there's this thing, I don't wanna cast aspersions on the road crews, but this seems to be appearing along hedgerows. Dirt roads and things where you would not expect it, and, I just wonder if there's some way that it's being moved around that way.
Aaron can correct me if I'm wrong, but I think this one's a native. So I think it might be sort of around, and as it's becoming more competitive, as we have longer growing seasons and warmer summers, it's just getting more of a chance to shine, as it were. How many of you know this one? Mile Minute Vine? This one's new to our state. It's more in the lower Hudson, and it's more in natural areas and field rows, but it's a thorny annual vine that can really take over vegetation, can show up in orchards. And this one, the seeds get eaten by birds and moved around that way, and they float and they just get everywhere. And so it's really important to manage it before the seeds start to set, because once the berries form, they'll go ahead and ripen off the plant, even if you harvest it. It is well managed by triclopyr and other systemic herbicides. And you can lay a pre-emergent down if you have a big population of it. And if you don't have the seeds on it yet, you can pull it, bale it up, and lay it out to desiccate before you try to get rid of it. And there's a biocontrol that you can buy now. So if you have this, or you know somebody who has it on their farm, that is an option. We already talked about this one. Glyphosate or 2,4-D works really well on it. Rotation into alfalfa, frequently mowing, as we already discussed. Early planted crops that develop a canopy before it emerges can help suppress it. And rotation into fallow or crops that will disrupt its life cycle. Yeah.
So hemp dog vein is related to milkweed, and 2,4-D doesn't do anything to milkweed, but it does the hemp dog vein. So what I want to say is be sure to read the label and be sure that the weed is on that label, otherwise you're going to be wasting your time.
We actually went back and forth about putting 2,4-D on the slide. So you're like, really? It does something for this? So I was happy to hear you say that earlier. Another perennial How many people struggle with this, if anybody? Yeah. We had a ton of it when we started the cropping systems experiment at Musgrave in Aurora. And it just spreads like crazy, and it really loves corn and soybeans. But when Chuck came in and he shifted the rotations so that they included a small grain, it just started disappearing because it interrupted its life cycle. So that worked really well for us. Any crop that has a late spring or early summer tillage will work great. Overtopping it with something dense. There aren't a ton of herbicides that work for this because it's not a grass, it's a sedge. But they're right there, and I think you're going to get these slides. So if it's too small to read now, you can look at it more carefully later. And it's just the group 2 herbicides that work as a post application. And I got those off of the Mid-Atlantic crop management guidelines. Have some amazing tables in them for what herbicide works best for what weed. This one is another one that we're worried about coming north. This is purple nut sedge. Does anybody have this on their farm? I see a few points for this just in Long Island right now, but it's probably going to come north. And it's apparently worse than yellow nut sedge, harder to kill. What Chuck had to say was extreme measures are generally required for its control, which I found a little disturbing. He talked a lot about solarization for this one, which they use a lot in the hot, dry Southwest. He said black plastic doesn't do anything because the shoots are so sharp, they just go right through black plastic. But clear plastic, the shoots come up, they get the light, and the leaves come out, so they're not as sharp. So they stay under clear plastic. So if you put out clear plastic on a really hot, dry spell of weather, that can kill the tubers pretty well. Great, pigs actually love to dig this up and eat it. So that's an option if you have a plant and animal farm. Otherwise, crops that have full closure and really deep shade, Sudan grass or something like that. And then lots and lots of tillage in hot, dry conditions that'll break up the runners. And so that you just have, the tubers separated and then pull the tubers out and let them desiccate at the surface. I don't even know if our weather gets hot enough for that. So hopefully we won't have to worry about this for a few years. That picture over there on the bottom is purple nut sedge coming up through asphalt. And then the bindweeds, which we all love to hate. Lots of tillage between crops. These guys are at their minimum storage in their roots at 4 to 6 leaves. So that's a great time to try to disrupt them with whatever tool you're going to use for that. The weather's really got to be dry after your disturbance or they'll just regroup. A fallow that's followed by wintergrains or another vigorous fall planted crop. Interseeded clover into corn can help keep it down a little bit. Really intense short shading early enough in the season that it hasn't gotten enough energy to climb up through the canopy can help. Forage soybeans, rye, oats, Sudan grass, German millet. Alfalfa that's mowed can help suppress the population. If you're working in vegetables, which clearly many of you are, overwintering rye, oats and peas, buckwheat, Sudan grass, disking between crops. And synthetic mulch works only for field bindweed. It doesn't work for hedge bindweed because hedge bindweed does more lateral growth when it's suppressed by something that prevents it from getting light. And it'll just go right out from under it. And that's all I got. Are there any questions? So if you want to contact Sophie for me. And then that upper site is the Weed Science website at Cornell, which is relatively new. We just put it up about 6 months ago. And it's got us and Lynn Sosnowski and Deepan Kumar, who just came on in January. And Jenny Cowniffin's stuff is all in one place. And then if you want more information about weed identification and management, we have a site for that too.
Okay, so we've talked about a lot of weeds. Any questions you have specifically about weeds that we haven't gone over yet? We've actually we've been collecting, farmers' favorite weeds for the past few months, and we have quite a list.
I have a question going back. When the slide said that Matthew short of 2 to 5 years.
Mhm.
Well, specifically, we have some good, really going to take over.
Okay,
Maybe when you said 2 to 5 years, does that mean each new
that means
seed crop that it drops, like you expect another 2 to 5 years?
yeah, so the lifespan of the plant is about 2 to 5 years. And I've done a little work with knapweed and actually called up a bunch of dairy farmers to see if they have it. And dairy farmers don't have knapweed. Some of them didn't even know what it is. And what I find is that knapweed is in fields that we don't manage very intensively. Maybe we harvest it for hay once a year. So I did a little trial where I mowed it like twice or 3 or 4 times and fertilized at different rates. And if we just manage our hay fields intensively, give it some fertility and mow it at least twice, preferably 3 times a year, it doesn't compete well. And then also Banbelt in August has worked, at least on one farm. So Banbelt has been fairly effective on it as well. Any other? We want you to get these weeds figured out, so if you don't ask your questions, you're not gonna get any answers. But, okay, I guess it's time for lunch then. And we're all here, so if you have questions, just ask us. I don't think there's any big instructions here, just the plates are on one end.